Assalamualaikum warahmatullahi wabarakatuh. Welcome back to more examples related to proving the trigonometric identities. And in this video, there will be two examples that I'm going to show you guys. So the first one is this, where you have sine squared theta plus sine squared theta multiplied with tangent squared theta is equal to tangent squared theta. So as a usual practice, I will always choose the more complicated side to work on. So I'm going to choose the left hand side. So consider the left hand side. So where I have sine squared theta plus sine squared theta tangent squared theta. And based on this expression here, I know that I can factor sine squared theta out. So that will be sine squared theta 1 plus tangent squared theta. So basically what I did was I'm just factor this out. So this is the common term that you have. So you can factor it out. Now next I can see that 1 plus tangent squared theta is a trigonometric identity. You can replace that with secant squared theta. So this is using the trigonometric identity which you have seen in the previous subsection, okay, subtopic. So now I'm going to replace that with sine squared theta. So this one will be secant squared theta. Now this becomes sine squared theta secant theta squared. So this is the same thing. Now what is secant? Secant is just 1 over cos. So 1 over cos theta squared, and that can be simplified to if you consider putting in sine theta inside. So you will have or you will just sine squared theta over cos squared theta, and this is the same thing as sine theta over cos theta squared. And what is this? Sine theta over cos theta, this is just tangent theta. So tangent theta squared, and this is the matches what you have seen on the right hand side of the equation. Okay, now let's look at the next example. Okay, this example. Right, let's say I consider the left hand side. So I'm going to consider the left hand side. Consider the left hand side where I have sine to the power of 4. So this one power 4 sine x minus, okay, the same term. And this is actually equal to, if you look at this, I can actually express it in terms of, this is similar to writing sine square x squared minus cos square x, and you square it. Okay, so to those who are not sure why this is as such, you need to brush up your knowledge related to power and exponent, which you have seen in the previous chapter. I can't remember what chapter is that, maybe chapter 3 or chapter 4, so you have to refer back to that. So 2 times 2 is 4, so that's why you can write it in terms of sine square x, and then outside is power of 2. Now if I look at this, I can actually say that this can be represented as a. So a is equal to sine square x, just so that you can see a simple form of it. So cos square x is b cos square x. So okay, so now I can write down the next step as, so this is just a squared minus b squared, and this brings a simple look to you guys, and maybe by doing that you can easily see that the expression here can be factored into a minus b and a plus b. So next, what I'm going to do next is I'm just going to replace what a is and b into this expression. So I need a bigger space for that. So a is just sine square x minus cos square x. A plus b is sine square x plus cos square x. And this one will be equal to 1. Okay, so this one will be equal to 1 because this is just a trigonometric identity which you have seen in the previous subtopic. So since that becomes 1, we have sine square x minus cos square x. So we are left with just this term. And we know that on the right hand side over here, we have only the term of sine square x. That should give you an idea where cos square x needs to be eliminated. So how do we eliminate cos square x? That would be by substituting cos square x with 1 minus sine square x. So we're using this identity here. Okay, again, we're using the same identity where you know that I'm just going to write down the identity in case you don't understand what's going on here. So we know that the identity that I'm using for this one and for this one is this sine square x plus cos square x is equal to 1. And because of that, this one will become 1 and cos square x will be 1 minus sine square x. So that's what I have over here. And next we can just simplify that further. This will become sine square x minus 1 plus sine square x. The common term here can be added. So we will have 2 sine square x minus 1. And this is the answer, which matches what you have seen here on the right hand side of the equation. Alright, thank you very much for watching. I'll see you in the next video with more examples related to proving the trigonometric identities.